Most database projects fail before the first line of code is ever written. Why? Because the design is rushed, or worse, skipped entirely. I have seen teams spend weeks coding only to discover the foundation was broken from day one. Suddenly, queries are slow, features can't scale. Fixing it means tearing everything down. But it doesn't have to be that way. In this video, I'll walk you through the actual process professionals follow to design reliable, scalable, and maintainable databases before touching a keyboard. We'll break it down step by step, from gathering the right requirements to translating them into a robust data model, to implementing and validating your design with data. The first key step of database design is requirement gathering. Requirement gathering refers to gathering the information about the database in different ways, such as talking to other people who will be involved with or using the database in the future, studying existing databases if there are any, and examining other relevant aspects of information management. To talk to other people who will be involved with or using the database, you need to organize meetings, ask good questions, and have conversations with different groups. Let's use the database of the online store, the Sci-Fi Collective, as an example. The Sci-Fi Collective happens to be a typical business. It has 2 owners, 1 manager, several staff who are responsible for tasks such as data entry and customer service, and 3 others who work on software development. For each group, you will need to prepare tailored interview questions, like these. If you are new to this process, you need to know that the generative AI tools can help a lot with this step. For example, you can ask for some example questions from ChatGPT using a prompt like this. Beyond interview questions, you need to prepare many other things beforehand, such as whether to take notes or record the conversation. If to record the interviews, whether you need to gain permission from the organization, how you want to record the interview, or even where to conduct the interviews. That's everything about the requirement gathering step. Now let's talk about the next step, analysis and design. The analysis and design step involves many tasks. Let's highlight a few important ones, such as identify the goals of the database, identify subjects, characteristics, and relationships. After that, you have data modeling and normalization. Let's go over these key tasks one after another. So we're going to start with goal identification. Undoubtedly, this is the first thing you should be doing based on the information that you gather from the last step, requirement analysis. Every database is created for some specific purpose, whether that purpose is to handle the daily transaction of a business or manage the information of an organization. You need to identify the goal of the database clearly because it will be used to help guide your other decisions down the road. So what would a goal look like? Let's use the same example of the Sci-Fi Collective. If you do the hard work to interview the owner, manager, staff, and software developers, you may summarize the goal of this database as this. The database of the Sci-Fi Collective is to maintain information about products, such as their inventory and reviews, and information about users, such as their payment information and purchases, as well as the transaction information linking users and products. In short, that's a typical database for an online store. So the next task is to identify subjects, characteristics, and relationships. To identify subjects and characteristics from the record of the interview, you can look for nouns in the responses to your questions. How do you differentiate subjects from characteristics? Typically, if you can build a sentence with 2 nouns in which one has or owns the other, the one that is possessed is a characteristic, and the other is the subject. What am I talking about here? Let's use an example to make this a little bit more clear. For example, you can put user and a password in the following sentence. A user has a password. In this sentence, the password is possessed by the user, so the password is a characteristic of a user, whereas the user is a subject. You need to perform similar deduction on interview conversations. For example, you might ask the following questions to an IT staff member working for the Sci-Fi Collective. What are the main tasks or activities you perform that involve data storage or retrieval? The participant may give you a response like this. This response, as you can see, is very detailed. The participant answered this question very well, with a lot of useful details. You can track all the nouns and see whether they can be used in sentences with verbs like has or ons to identify subjects and characteristics. However, in real world, you may need to ask a lot of follow-up questions to solicit such detailed information, and that's why experienced interviewers actually start identifying subjects and characteristics as soon as they start the interview, so that they can track which answer is vague and whether follow-up questions are needed immediately, which will save a lot of time down the road. If the transcript of the interview becomes very long, you may also seek the help from generative AI with a request like this on the left side of the screen that says, "Help me identify the subjects and their corresponding characteristics from the transcript of the interview." However, you can't blindly trust AI to do this job perfectly. You will need to double-check and make possibly a lot of small or big revisions to the work of AI. If this task is carried out accordingly, you will at least be able to summarize 2 subjects and 4 characteristics from this snippet of the interview. The 2 subjects are user and order. User has 2 characteristics, account and a payment method, because you can put them in sentences where verbs are either has or ons. Similarly, order also has 2 characteristics, product information and total price. If you do all the hard work required by this task, you will be able to identify these many subjects and their characteristics for the database of the Sci-Fi Collective. You will also be able to identify the following relationships, represented as a bunch of sentences. By relationship, I mean the connection between 2 different subjects, and characteristics don't really play a role here. For example, we know that user and order are 2 different subjects, and their relationship is summarized here in the first item. A user can make multiple orders. An order can be made by only one user. With this information, you will be able to actually engage with data modeling. So data modeling aims to create a conceptual design that shows how the parts of a database fit together and relate to each other. The conceptual design is typically represented visually as an entity relationship diagram, or short for ER diagram. For example, the ER diagram of the Sci-Fi Collective database may look like this. I know that this diagram on the screen contains symbols and syntax that you don't understand yet. They will be covered in detail in the future videos. When an ER diagram is drafted, the next task is typically normalization. So what's normalization? Normalization is about breaking down a table representing more than one entities into smaller tables. For example, someone designed a table product_review to hold data of both products and their reviews. You know that storing information about more than one entity in the same table can lead to redundancy and anomalies. You could fix this bad design by breaking it into 2 different tables, product and review. So this is a snapshot of normalization. While the details of normalization are more nuanced, and this concept has a set of clear defined theorems that can guide your actions, which we will cover in the future. Now, you have some basic understanding of what needs to be done, and the second key step. Let's move to the next and the last step. The implementation/integration and the testing step involves building and validating the database based on the blueprint you made in the design and analysis step. At this step, you will convert your ER model to SQL code that creates the corresponding database and tables. After that, you will populate the database with sample data to test 3 aspects of the database, including functionality, You need to check whether the database performs the expected tasks correctly, such as creating, updating, and deleting data entries. The performance. You need to check how well the database handles a large amount of data or heavy use. Then, the last one is security. You need to verify that the database has appropriate security measures in place to protect sensitive information such as passwords or payment methods. Based on the testing result, you may need to revise your design or fix bugs that you have identified. In case if you ever wonder where the test data can come from, it can either come from your client, the person or the people you are designing the database for, or you can easily simulate such data with the help from generative AI. For example, you may derive an ER diagram from the analysis and design step like this. You can ask generative AI to help you generate sample data for your targeted database system. You can even make sure that the sample data is already in a series of insert commands that's ready to use. This is a task that generative AI excels at. In this video, we went through the 3 key steps in designing a database, including requirement gathering, analysis and design, and implementation/integration and testing. If you find this video helpful, give it a thumb up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You'll find the link to the book in the first comment.